Hi everyone, I'm Sridhar at E-shikshana. In this video, we'll discuss few sensors and transducers. We discuss a proximity sensor, pneumatic sensor, light sensor, tactile sensor, smart sensor, fiber optic transducer. First, we'll start with the proximity sensor. Proximity sensor consists of an element that changes its state or an analog signal when it is closed to the object but not actually in contact with it or in touch with the object. The methods suited for the designing of proximity sensors are magnetic, electric, capacitance, inductance, eddy current. Another method used using photoemitter detector pair, in which an interruption of reflection of a beam of a light is used to detect an obstacle without contacting the object. Some common applications of proximity sensors are counting moving the objects and limiting the transfers of a mechanism. There are three methods of designing proximity sensors: eddy current proximity sensor, capacitance proximity sensor, and inductive proximity switch. First, we'll start with eddy current proximity sensor. The eddy current proximity sensor consists of a sensor coil and the reference coil, as shown in the diagram. The working principle and construction we are going to discuss. A coil is supplied with an AC current which produces alternating magnetic field. If there is a metal object in close proximity to this alternating magnetic field, then eddy currents are introduced in it. The eddy current themselves produces a magnetic field which destroys the magnetic field responsible for their production. Consequently, the impedance of the coil changes and also the amplitude of the alternating current. The advantages of eddy current proximity sensor are small in size, relatively inexpensive, it is highly flexible, and high sensitive to small displacements. Next, we'll discuss capacitance proximity sensor, which consists of a coaxial cable and a sensor plate, and the object acting as the plate, which is grounded. It consists of a simple sensor plate with earth acting as the another plate. As the object approaches the sensor, separation between the plate of the capacitor and the object changes. So that is detected by the capacitance effect, which becomes significant as the object is close to the sensor. Next, we'll discuss about inductive proximity switch. An inductive proximity switch consists of a coil wound on a core. When the end of the coil is close to a metal object, its inductance changes. This change can be monitored by its effect on a resonant circuit, and the change is used to trigger a switch. It can only be used for detection of metal objects and is best with the ferrous metal. Next, we'll discuss about pneumatic sensor. The arrangement of a pneumatic sensor is shown in diagram. It involves the use of compressed air, displacement or proximity of an object being transformed into a change in air pressure. The low pressure air is allowed to escape through the ports in front of the sensor. This escaping air, in absence of any close by object escapes, and in doing so also reduces the pressure in nearby sensor output port. If there is a close by object, the air cannot so rapidly escape, resulting increase in pressure at the sensor output, which is shown in figure B. When an object is placed in front of the arrangement, the air cannot escape easily, which is being blocked by the object in front of the arrangement. Pneumatic sensors are used for measurement of displacement of fractions of millimeters in range, which is typically about 3 to 12 mm. Next, we'll discuss light sensors. The types of light sensors are photodiodes, phototransistors, and photoresistors. First, we discuss about the photodiodes. It consisting of arrangement shown in the diagram, which has a P region, N region, and an anode forming a PN junction with a diffusion of SiO2 mask and a silicon nitride coating. The working principle of photoelectric effect. When the junction of two terminals semiconductor devices is illuminated, then an electric current starts flowing through it. Only minority current flows through the device when a certain reverse potential is applied to it. To allow the light energy to pass through the PN junction placed inside the glass, as only the junction is exposed to the radiation, thus the portion of the glass material is painted black or metallized. The overall unit is very small, nearly about 2.5 mm, and it has a very fast response to the light. Next, we'll discuss on phototransistors. The phototransistors have light sensitive collector based PN junction and is a three-layer semiconductor device which has the light sensitive base region. The base senses the light and converts it into a current which flows between the collector and emitter region as shown in the diagram. When a light incidents, a base current is being produced, so that is directly proportional to the light intensity. This leads to production of a collector current is then a measure of the light intensity. In a Darlington arrangement, the two transistors are connected back to back as shown in diagram. In this arrangement, the phototransistor include much higher power, that is their sensitivity rises. Next, we'll discuss the photoresistors are also known as light dependent resistors, LDR. The diagram shows a basic construction of a LDR which consists of a plated electrodes on a photosensitive track. It has a resistance which depends on the intensity of the light falling on it, decreasing linearly as the intensity increases. The cadmium sulfide photoresistor is the most responsive to light wavelength shorter than 515 nanometer, and the cadmium selenide photoresistor for wavelength less than 700 nanometer. An array of light sensor in small space is required to determine the variation of light intensity across the space. So this is about the photoresistors. Next, we'll discuss on tactile sensor. A tactile sensor is a device that measures information arising from physical interaction with its environment. A tactile sensors may be different types, including piezoresistive, piezoelectric, capacitive, and electroresistive sensors. Some of the construction of tactile sensors are shown in diagrams. So there are different types, including the different materials for the construction. We'll discuss on piezoelectric tactile sensor. It uses polyvinyl fluoride sheet which has a photoelectric qualities. A soft film is sandwiched between two layers of PVF2. The soft film transmits vibration. The principle uses in both is piezoelectric and its reverse effect. When an AC voltage is applied to the lower layer and as a result generates the vibration, which is a reverse piezoelectric effect. These vibrations are picked up by the soft film and transmitted to the upper layer, which converts these vibrations to alternating voltages, which is piezoelectric effect. The tactile sensors are used in robotics, computer hardware, and security systems. A common application of tactile sensor is in touchscreen devices on mobile phones and computing. Next, we'll discuss on smart sensors. Sensors having decision making and a communicating logic added to the basic sensors are called smart sensors or intelligent sensors. The features of these smart sensors are compensation for interfering inputs, linearization, self-test, calibration facilities. The figure shows the functional diagram of the data acquisition system of a smart pressure sensor, which consists of a primary sensor and a secondary sensor. The outputs of these are connected to a to D converter, which in turn connected to a microcontroller with a memory and a IO interfacing with user computer system. When a piezoresistive sensor is used as a primary sensor for pressure, the main interfering input is a temperature, and so a secondary temperature sensor is used to compensate for the effect of temperature on resistance change. The memory of microcontroller has calibrated data stored in it. The microcontroller is essentially a microprocessor with input output facilities. The application of smart sensor is conditioning monitoring system for a plant to monitor the health of machines and processes to detect the possible damage. Instead of using a dedicated computer with spectrum analysis and data acquisition system or a signal processing and pattern recognition, this system can inputs from the various sensor processes the signals and diagnose the fault if any and communicate. This would be requires quite economical for plants. Next we'll discuss fiber optic transducer. So it works on the principle of alteration of light by external variables like motion, temperature, pressure, flow, strain, pH, particle size, etc. The fiber acts as light conduits to a conduct light and consists of a thin strands of a dielectric materials like glass, quartz, and plastic. A light ray propagating in a fiber is trapped by total reflection at the boundary of the core and cladding materials. This is possible when N2 is less than N1, as shown in figure, where N2 is refractive index of material and N1 is refractive index of core. Types of optical fiber sensor configurations. An optical fiber sensor emits maybe light emitting diode or laser source. Emitters emit the light ray through fiber which gets modulated due to the outer signal which is to be measured. The output fiber is connected to a detector which converts the optical energy into electrical energy. There are mainly two types in optical fiber configurations: extrinsic or incoherent sensors, intrinsic coherent sensor. First, we'll discuss on extrinsic or incoherent sensors. This type is shown in diagram. The intensity modulated of lights takes place outside the fiber. So you can see the emitter and the detector and a modulator. The intensity modulation of light which is energizing from the outside signal. The next arrangement shows the extrinsic or external intensity modulator type, of which the position of the reflector due to the motion to be measured may change. The change in light intensity in the output is detected by the detector. The next configuration shows a typical fiber optic flow sensors. The frequency of the light waves scattered from the particles in the moving fluid is a Doppler shift, the frequency shift being proportional to the velocity. The input optical fiber carrier light which is focused on the fluid flow. The output fiber carries the light scattered by the particles in the following liquid, and particle velocity is found from the modulated frequency spectrum. Next we'll discuss about coherent or intrinsic sensors. In this type, the intensity modulation of light takes place within the fiber. The second figure shows the example of intrinsic type sensor. Here the fiber bending due to the pressure, which is the input variable induced radiation losses, changing the intensity of the output. This happens within the fiber itself, and hence the configuration is called intrinsic type. This causes the radiation of light even small deformation and is also called micro bend sensor. There may be a phase or frequency modulation along with the intensity modulation, and it can be used for many applications for measuring the phase or frequency. In the next video we'll discuss few more sensors, and don't forget to hit a like button and subscribe to our channel. Thank you.